all devices without exclusion. And what we set up to do back then was to really look, I mean, what is the most extreme case for those containers? Because there have been players trying to bring container technology to those various devices, but we picked OpenWrt because of you guys have like a rockstar connectivity platform that fits on super small devices and that is used by millions of users, and we want the container technology to be useful there. So who of you has used Docker? Almost everyone, right? So everyone has used Docker. But who of you knows how to use containers on devices? Okay, that's not so bad. Because what we found out is that we feel the market is kind of confused still about how to use container technology for real on devices. And what Docker really did when they launched, they solved that problem for the cloud. Before that, containers was great kernel features, we had namespaces, C groups and so on, but I mean, how is the experience? How do you use containers in the cloud? They solved that, they put out something very great. And we believe that that's not, I mean, Docker is not solving the problem for devices. So what we did, we looked basically, what is the difference of the cloud and devices? And obviously one thing is size. So the cloud, nobody cares about size, right? They put like a Go binary on it, 20 megabytes, bang, the router would be dead, like no more space left. So you cannot run anything on it anymore. The other thing is in the cloud, you're in a controlled environment, so you can be in the driver's seat, you can deploy, you can monitor those containers, you can shoot them down, you can do stuff. It's not like here where devices might not pop up for a month and then they suddenly show up and we want to roll software to it. And the other one is that in the cloud, you only care really about apps. Nobody cares about the operating system or the kernel, because in the end, it's spinning up machines, they come with the system, with the image, and so on. So we basically took a step back and tried to solve that problem for all of you. And what we would like to see is that you take a look at our technology, give us a feedback, and work together with us so it becomes something that you at least have used for your development or potentially even for products in early stages next year when we meet again. And now Ricardo will explain to you what we did and how the technology looks like.
All right. Okay, so as he said, containers on devices is not the same as containers in the cloud. Completely different use case, right? The architecture we have put together is based around two projects. One of them called Pantavisor, the other one called PantaHub. Okay? So this is a very, very high level overview of how this looks like. Pantavisor is a small, very lightweight init system, right? You boot straight to it. It is written in C. It's super tiny. It fits in OpenWrt devices without problems. And its sole purpose is to drive container execution. Right? So what does that mean? That means that, following a specification document that outlines how your assets, your objects, your rootfs are laid out in the system, a container runtime can be instructed to basically bring up all those containers as you need them, right? In this specific example, of course, you can see that we're taking a normal OpenWrt rootfs and we're making a full container out of it, right? This is without changes, right? This is just a normal rootfs, which is one of your build assets. That's perfectly fine. We take it and we run it through very lightweight containerization. We're not talking about, all the things, all the super orchestration systems and so on to deploy Dockers on the cloud and whatnot, right? Because that's not what we're really after here. What we're after is the agility of using container technology to drive firmware stacks. So you can call it in a way kind of like firmware containers, right? As I said there, well, container updates, kernel init RD updates, Pantavisor being a small init system takes care of all of this. Now, how does it take care of all of this? Well, it has a counterpart, which is PantaHub, right? PantaHub is the cloud service. This cloud service gives you a user registry, a device registry, and an object store, okay? So that Pantavisor-enabled devices can be driven from this cloud service, and the state or specification documents that drive and basically outline how those containers should be run on each device can be delivered from the cloud to those devices. So ultimately, you find a way to represent the devices in a very simple, flat way, right? This has huge implications for operations. Right? The ability to drive updates forward super fast and, just define with a very simple specification document a set of objects that come together to form a container, that is very much invaluable. You can gain the use case, for example, of course, of delivering a parallel app, straightforward, right? If I already have a very lightweight OpenWrt container running, taking care of my networking, then I'm going to have another app in parallel, which is just another very lightweight container, which I can drive from the same Pantavisor and through the same heuristics. All of this is completely open source, of course. We actually put it online yesterday. You can see the URL everywhere. It's on GitLab. Pantavisor is tiny, 350K. You know, no overhead, a couple of megs in memory, perhaps. Both sides are completely open. The cloud as well, PantaHub, right? So you can go to GitLab, you can take it, you can deploy it yourself in your infrastructure, you can try it out, right? That's the general concept of the architecture. Now, if you don't want to deploy, for example, PantaHub yourself, then you can go to PantaHub.com, right? That is our own, you know, sort of a early stage alpha, deploy your own service, right? You can go to PantaHub.com, try it out if you're not interested in doing all the DevOps and so on of deploying the service yourself. From here, PantaHub.com is not just a hosted version, but it also brings the features that really make it an ecosystem, right? So in PantaHub.com, you can register for an account, you know, you can register and begin uploading your firmware. You can think of PantaHub like a GitHub for firmwares, literally, right? Let's say that I build up, I don't know, a specific firmware for one of the devices that I saw today, 16 megs, small, tiny OpenWrt device. I realize I can put a parallel container in it to drive like a Bluetooth IoT gateway ecosystem, you know, like something like that. And I decide I want to share that with someone else, right? I can just put it over there. I can push it just as if I was doing git push somewhere, right? And somebody else can clone it because of the fact that I'm defining the systems in such a simple way. I push, people clone, people share it, people give feedback, people push their own versions, people fork things. It's the same thing, right? You can see your lists of devices, you can see the details of them, you can see which ones are open, you can share some of them, some of you can keep private. This is just a visualization interface. That's all that it is, right? But it is ready to use right now. It is, you know, it is the first take at it. What we're really interested in right now is getting all the feedback from you guys, seeing if any of this hits close to your heart, right? See if any of this interests you, please, you know, get in touch with us. You can see the code on GitLab. Everything is open source, as I said, top to bottom, even the website. The presentation is not, but you know, everything is open source. You can go there, get in touch with us. We'll be here today, tomorrow. Catch you later for a beer. And well, thank you for hearing about PantaHub.
Okay.
Do you want to just introduce?
Yeah. Okay. Hello again. So I worked for the first year as a mentor for the Google Summer of Code, and I submitted a project that was basically at a company where I worked two years ago, basically using Multipath TCP. So Multipath TCP is a kernel patch that's being developed originally at my University Catholique de Louvain in Belgium, and is still actively maintained. The main developer was recruited by Apple, and now it's being shipped in most of the iPhones. I was looking for a student to port that stuff to OpenWrt and actually make something out of it. And I found a very interesting and very motivated student from Hungary. So, Ferenc, up to you.
Thank you for the introduction. Welcome everybody. I'm Ferenc Fejes from University of Debrecen, Hungary. And it's just a brief introduction of my Google Summer of Code project, which was basically integrating the Multipath TCP into LEDE, and after that we made a transparent proxy, so devices like phones, tablets, PCs, which don't support natively the Multipath TCP, can use the benefits of multiple ISPs or multiple network connections. So tomorrow morning at my workshop, we reproduce this topology. So basically there are two end hosts without any Multipath TCP support. They only support regular TCP. Here's OpenWrt routers, which supports Multipath TCP, and there are multiple Wi-Fi links, Wi-Fi connections to them. Because they are close together, they are put the two Wi-Fi paths into different frequencies, so they don't interfere with each other. Here's a video. I try to show it. I hope it works. Yeah. Try to speed up. It's an iPath between my notebook and my PC. Both of them, they use regular TCP. The routers intercept the TCP and use multiple paths to multiple Wi-Fi paths. After I put back the cable, another link becomes active again, and the aggregated speed shows up between the end devices again. No, that's for the another link. We need some work on this subject, because the proxy which currently uses shadow socks, it's only use one CPU core at once. So even if we have multiple CPU with multiple cores, it's we don't get any benefits from that. It would be nice to have a precompiled kernel package for that, because it's only we have a GitHub repo yet. So if anyone wants to try out, it needs to download it and compile it manually. And yeah, basically, it would be nice to have a ISP ready solution. And here are some links. Link to the video, which is shown recently. There is a blog post about the work, and here is my GitHub repositories to the modified version of shadow socks. The modification is just make the encryption mandatory for very low speed CPUs. And
actually, it's removing. So the story is that the main author of shadow socks is very focused on security and doesn't want to have an option to do not have encryption at all. So during his work, we found out somewhere on GitHub that someone actually made the work to patch shadow socks to have this no encryption feature, and that's basically he created another OpenWrt package to have this no crypto option. So yeah, probably we're gonna have to keep that thing outside of shadow socks because the main author doesn't want to get inside. But okay, we were lucky that we found this patch during his work.
Yeah, and there's a repository. I show it quickly. It's currently have 2 branches. A stable branch, which is based on the stable LIDI and the stable Multipath TCP patches, and there's a master branch, which is currently support kernel 4.4 and 4.9. Yeah, but that's unstable version of Multipath TCP and unstable. Yeah, this is currently unstable. So thank you for the attention.